Hello again. Today, in this part, we will talk about plotting functions, regression analysis, and Monte Carlo. Yeah, and I'm quite excited about Monte Carlo. But before we start, I would like you to refer to a website with new code that is covered in this lecture. Yeah, and the link to this website can be found over there. Yeah. Okay, so I think that we can start. In base R, there are two types of plotting functions. The first type are so-called high-level functions, and the second one are low-level functions. We will discuss the difference between both types very soon, but first let's focus on the most basic plotting function, namely plot. Yeah. And to illustrate how this function works, we will use preloaded data frame cars, and this data frame has 50 observations and 2 rows, speed and dist. To read about the description of this data set, we can type help cars, and then we see that this data frame stores results of experiments. How much time does it take to stop if you start stopping at a given speed? Yeah, so there is correlation between required distance to stop and speed. Yeah, and this was recorded in 1920s. Yeah. So if we want to plot this relationship of cars, we want to write how distance depends on speed. Yeah, and to refer to column this, we have to use $sign, just like for data sets. Yeah, so we are interested in this against cars speed. Yeah. If we type this here, it plots on x-axis. This is what is on the right hand side of tilde, and on y-axis there is distance. So we see here positive correlation. Yeah, and actually it makes sense. Yeah, that if my speed is higher, it takes much more meters to stop. Yeah, and the same plot can be generated with referring only to name of columns, but then we have to provide argument that we are interested in elements from data called cars. And yeah, and this is the same thing. Yeah, the only thing is that instead of cars $dist, we have distant. Yeah, and but apart from this, this plot is both plots are the same. Do you like this function? Me neither. Yes, so this plot is not very informative here because we don't know what it is actually. Yes, so it would be nice to provide some better description of this plot. Yeah, and that's how we will talk about providing some additional functions. Yeah, and how can we check what options can be provide in for every function we use. Yeah, there is help or question mark. Yeah, and our function. So here we have the documentation. Yeah, and for instance, what we will change is that we will provide label for x-axis and label for y-axis, and some title that is informative at all. Yeah, because right now there is no title. Yeah. So if we want to, so let's copy this line here we have, and if on our x-axis we have speed, and we type xlab and provide the string that will be used as the label x-axis, yeah, and in our case this is speed miles per hour. On y-axis there is stopping distance, if I recall correctly, yeah, stopping distance in feet, yeah, and if we want to provide the title, this is what? Cars speed versus stopping distance in 1920s. Yeah, and hopefully now we will get a bit nicer plot. Yeah, and yeah, so this is it. Now suppose that we want to add some additional elements to our plot, yeah, and those so-called low-level functions are designed exactly for this purpose. Yes, so if we have one plot generated with high-level functions, low-level functions allow us to introduce new elements without resetting the whole plotting space. Yeah, and some of examples of low-level functions can be found over there. Yeah, for just a moment. Yeah, and now we will use which function? I think that it will be AB line. Yeah, AB line. Yeah, so suppose that we want to plot horizontal line that goes at the level 40. Yeah. Then we provide AB line, and if we want to plot horizontal line, in addition to add to our existing plot, we type H and the value that at which we want to plot. Yeah, and it's, yeah, let's say not 40 but 42. Yeah, because this is answer to the question of the word. Yeah, so that's this line. Yeah, and if we want, on the other hand, if we want to plot vertical line at the level of, I don't know, 21, yeah. So if we want to plot vertical line, then, yeah, not many of you will be surprised that we will use V. Yeah, and we provide here. Yeah, so this is it. Also notice that here I run two low-level plotting functions. Yeah, so those elements were added to existing plot, and the second time I used AB line didn't reset the previous result. Yeah, so it's like putting new stuff on the existing plot. Yeah, but and then you cannot change what happened before. Yeah, and this is it. Also, if we want to plot a line with intercept 0 and slope equal to half, then we can use, instead of H and V, we can use A and B. A is the slope of our line, the intercept of our line, and B is the slope. Yeah. So if we type this, we have additional line. Also notice that here we plot that there is only part of the plot that we see, and in particular, if we make mistake, for instance, here the lowest level is 0, and if we generate a line that for those values is not in the interval of 0 or 120, then basically this line somehow will be plotted by R in memory, yeah, but we won't see it at all. So for instance, if we type this, there will be no result for us at all. Yeah. On the other hand, if we want to reset everything, we just type plot, which is high-level function, and this resets the hot-level plot and generate the new one. Yeah. But right now, so before, this line didn't have any effect. Yeah. But if we change interval of y's that are shown, for instance, to y lim, and here we provide the minimum value, let's say -50 and 120. Oh, oops. Sorry. And if we plot this, yeah, we have new interval here. Because of this, you may be wondering that there is no 120. There is, but it's not. It's not on our y-axis. Yeah. And now, if we plot this function once again that didn't shown previously, yeah, it will be shown. R allows us to customize some of the plotting options, and for instance, if we want to change the color of our object, yeah, and let's say that we're plotting our horizontal line at the level of, I don't know, 37, yeah, 37 is here, yeah, and oops, sorry, and if we provide argument col, this is color for all plotting functions, yeah, and if we go here, yeah, in this file that I mentioned to you today, I uploaded first one file with colors in R. You can use either numbers or names of colors, yeah, and so here you have 8 pages of colors in base R, yeah, and yeah, here also we have cheat sheet here with the most basic functions that, yeah, you can print it and put it somewhere over your bed or whatever. Yeah, yeah, so here there are many colors, yeah, and let's say that we will use one of my favorite ones in R, medium purple. Yeah, and you see, now we have a different color. If we want to increase the size, the size of our line, we can increase this by changing this argument LWD to something higher, which is than 1. Yeah, and now it's yeah, it's bigger. Also, what we are able to change is the style of the line. Yeah, and for this, let's use orange. And for this, we use line type. Okay, line type, and in our and here we have different line types. Yeah, so for instance, if you want dashed line, it's enough to provide either this argument to, this numerical thing, or dashed. Yeah, and so we do it this to. And let's change, make it higher. You see? Yeah, now we have new style of this. Yeah, and yeah. So this refers to lines. Also, another type of decoration that may refer to points. Yeah, and for instance, if we want to, so here we plotted points. Yeah, those are points by default. If we don't write explicitly that we want to have line, plot function will plot points, yeah, and here I think that this should be messy, yeah. Oh no, it's not that messy. Yeah, so here it generates lines, yeah, but suppose that we want to have plots, yeah, so instead of type, yeah, so if we provide type equal to L, this is line, type equal to P are points, but if we skip this, by default it's they are points, yeah, and yeah, and if we want to change the style of our point, we can type, yeah, here we choose one of those numbers, yeah, and for instance, let's say, I don't know, 10, yeah. If we provide PCH equal to 10, then we have different style, yeah, and the same thing refers to if we type line and then we write LTY and we choose, for instance, for.def color blue, yeah, we will get this type of plot. The fact that some of those plotting styles can be called using either strings or numerical values is very useful, yeah, and let's to illustrate this, let's use a very standard dataset iris, yeah, and this dataset has 150 observations and 5 columns, yeah, and if we want to plot what's the relationship between sepal and petal length, we plot this just like this, yeah, but here in this dataset, what also we have is species, yeah. This column is factor, yeah, and the nice thing about factors is that we can translate this to numerical values by coercion, yeah. So instead of typing, yeah, instead of calling exact species, we don't care about this. We translate those species to some numbers, yeah, that all observations of the same with the same number are of the same species, yeah. And why is it useful in plotting? Let's take this, and here we are able to provide as a style, plotting style, this species, yeah. So here in our two-dimensional plot, we are able to introduce the third dimension, yeah, that the style of those points is our species, yeah. Let's see, here we can go even further, yeah, because also colors are associated with some numbers, yeah. So here not only different species have different the different style of points, yeah, but also different colors, yeah. And this is the most basic approach. Using lookup tables, we could translate species to our desired styles, yeah, but we won't do it, yeah. It's quite easy, yeah, but it will take too much time to do it right here. What if we want to draw two plots inside two or more? Yeah, many plots inside one plot object. Yeah, R allows us to do it. Yeah, and here let's load data set called cars93 from package mass. Yeah, and now we are able to use this data set. Yeah, before it wasn't loaded. Yeah, and if we type car93, yeah, we have new data set, and now we can plot what how horsepower and fuel efficiency, which here is expressed in miles per gallon, was the relationship here. In the city, yeah, miles per gallon in the city. Okay, yeah, so this relationship is negative. More powerful cars have lower fuel efficiency. Yeah, and it makes perfect sense. But now, what if we want here cars 93, and there is a column called origin. Yeah, and in particular, we can type just like before. Yeah, and here we have depending on origin, we have different style of plotting. Okay, but here it's a bit messy and it's not very informative. It is somehow informative, but it's not very. It's hard to read it. Yeah, so instead of this, we could try to plot two plots, one for US cars and one for non-US cars. Yeah, and this is what we're gonna do. So now we will tell R that we want to place two next high-level graphic options inside one very large plot. Yeah, and how to communicate this to R? We type par and provide fm row equal to some vector. And here we provide how many we provide the matrix dimension of our very large plot. Yeah, and we say how many rows there will be in our new plot and how many columns. Yeah, so if you want to have two plots next to each other, yeah, in horizontal orientation, we have to type something like this. And then if we type this, and let's use our old code. Yeah, you see that there is small space here where we plotted this figure, and if we run another high-level plotting function, this will be allocated here. Yeah, just like here. Alternatively, if we want to have this, two rows, one column, it will work. Yeah, it's not the most visible right here. Yeah, but the previous option is much better. Yeah, and yeah, so 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 now, and if we want to return to the default mode, it's enough just to type fm row, and we want to have one row, one column, one very large picture. Yeah. If we want to plot a separate figure for US and non-US cars, we have to proceed as follows. Yeah, so we want to have one row, two columns, yeah, and let's do it this way. This integer. So here we eliminate the name of data frame, and we use argument data equal to cars 93. Yeah, it works just fine. And now, if we want to condition our dataset only to those observations that have origin, what types table? Yeah, so here we have one. We will create one figure for US. So we choose all those rows where origin is US. Notice that here I need to provide cars $, yeah, and we can write main US cars, and the same thing we can either write here non-US or exclamation mark equality, which is not US, yeah, non-US cars, and here we type this. Yeah, you see, now we created two figures, one for each category of origin. Yeah, and this is how we can plot two different figures inside one very large plot object. An alternative approach to plot two figures involves using function Coplot. And in function Coplot, we use plot exactly the same, but here using the sign, we tell R according to which variable the whole dataset should be split into smaller subsets drawn individually. Yeah, and here we also provide data. Yeah, and I think that this is it. Qualitatively speaking, we get exactly the same plot as before. Yeah, maybe it looks a bit different, yeah, but here we have two plots that are generated on the basis of levels of category origin. Yeah, and this such a plot is generated here in this way for variables that are factors, just like here, and and this is it. Also, what is worth mentioning is that here we have additional grid, and in the original object function plot, if we want to introduce grid, we can use one of those low-level graphics function, and the name of this function is grid. Yeah, so we put on our existing plot, we put additional grid. A nice thing about Coplot is that everything is automated, yeah, and it is done by R4, yeah, and we don't have to care about how many categories they are. Everything is, yeah, everything is super smooth. And but also what is quite important is that Coplot works on also with categorization with respect to continuous variable, numerical variables, yeah, and here we will use example of dataset quakes. I have no clue what this dataset is about right now. At some point maybe I knew, yeah, but now it's not important, because here we can coplot latitude and length, I guess, lat against long. If we plot if data quakes, we'll get something like this, and we can make coplot with respect to depth. Yeah, so we can introduce additional dimension, and we can split our data set with respect to different values of depth, which can be, what is important, yeah, there are not only 2 or 3 categories, there are many values, yeah, and now if we type coplot data quakes, yeah, you see that here we have our data set is split with respect to different values of depth, and for each interval there is one plot of relationship between lat and long, yeah, separately. Yeah, and I should mention that yeah, so this interval of depth relates to this figure, yeah, and again this interval to this figure, this to this, and yeah, this is 4th interval, a very long one, yeah, which relates to this, yeah, and in this procedure, number of intervals and figures, and also overlap between those different intervals is chosen by function coplot, yeah, and I mentioned overlap because notice that here we have some observation. Here we have some area where there are two intervals overlap with each other, yeah, and in particular it means that some observations from this figure are also in this figure, yeah, and yeah, so this is it. But that being said, we are able to change it, yeah, and here to change this we can generate our object of given depth, and this is function intervals, co-intervals that split the variable of our interest. Here this is depth, and it splits in. So suppose that we don't want to have 4 categories, but 6 categories, but for instance 4 categories. We type number 4, and also there is function overlap. Yeah, so if this overlap is, it means what's the percentage of observations that are in are in 2 categories, yeah, and this is it. This function co-intervals generate a matrix of intervals, yeah, of lower bound and upper bound of each interval, yeah, and we see that because we chose number 4, yeah, we have 4 intervals. Yeah, and now we can plot. We can use this function once again, but now we can provide this this object generated with co-intervals as, and I don't remember the name of this option, given values. Yeah, so given values or given depth. Yeah, we see now we have 4 intervals. Yeah, and if we don't want, and still, and here overlap is smaller than before. If we want to reduce this completely, yeah, we see that we see here that that there is no overlap at all. Yeah, and yeah, so this is about this function coplot. The very last plotting function that I'm gonna discuss in this part of the lecture is bar plot. Yeah, and here actually this is self-explanatory what it does. So let's create such two objects, month, May, June, July, August, September. We have those 2 objects, yeah, and now if we want to, yeah, this is it, yeah, and if we want to provide those labels of months below on the x-axis, we type names argument month. Yeah, yeah, and yeah, so it's, yeah, it is what it is, and I think that this is it for this part of the lecture. I believe that also I would cover Monte Carlo simulations in this part, yeah, but it turned out that it took much more time for explaining plotting than I expected. Yes, so in part 3 I will start with introduction to loops, which we need to conduct our first Monte Carlo simulation. Yeah, so yeah, see you in, yeah, see you soon.